here you are, welcomed softly by Dreamtime Science in the silence of a starlit evening. Picture a quiet library, tall windows revealing the velvety night sky, scattered with shimmering lights far, far away. It's a place where the mind may wander freely, where every word floats like a gentle breeze across your thoughts. If you feel at home in these stories, a quiet like or a subscription would help light our way, and do share a note in the comments about the peaceful place you're listening from. Now, take a moment to find perfect comfort. Adjust your position, perhaps turn over on your side, and breathe in the calm that night brings. We are ready to begin our gentle exploration now, together, letting every whisper of science bring you closer to rest and wonder under this soft, endless sky. Tonight we'll be gliding very slowly, very gently through the velvet night, exploring the glowing, cloud-like wonders known as nebulae, cosmic nurseries where stars are born. From a safe, pillow-soft distance, we'll watch these shimmering veils of stardust whisper their ancient secrets, inviting our curiosity to drift among the dreams of the universe. Let's begin this quiet journey into the heart of celestial mystery. A gentle like or subscribe tells me to keep these calming explorations flowing. I'm always curious. Which stars are watching over you as you listen? Before we begin, create your sanctuary. Nestle into your chosen spot. Let your muscles soften and allow your breath to find its natural rhythm. The night sky, in its infinite expanse, unfurls a velvet tapestry scattered with pinpricks of light, each one a distant sun, its brilliance softened by the vastness that lies between. Yet for those who peer more deeply, aided by the patient gaze of telescopes, the universe reveals another layer, at once more elusive and more magnificent. Nebulas, those luminous clouds of gas and dust, float in the interstellar dark, their forms at once ghostly and majestic, painted in hues that defy the ordinary palette of earthly skies. They appear as if conjured by the dreams of ancient gods, or as the resting places of celestial dragons coiled in their eternal slumber. Through the eyepiece of a telescope, a nebula is not merely seen, it is encountered. The observer is drawn into a cosmic reverie, at once intimate and infinite. Take, for instance, the famous Horsehead Nebula. Even its name invokes the language of myth, as if it were a spectral steed galloping across the Orion constellation. In reality, this nebula is a dark cloud of obscuring dust, silhouetted against the radiant backdrop of ionized hydrogen gas. The Horsehead's profile is so evocative, so distinctly equine, that it seems to have been sculpted by a cosmic artisan. Artists, inspired by its uncanny form, have immortalized it in paintings and digital renderings, their interpretations swirling with colors our eyes cannot perceive unaided. The pillars of creation, immortalized by the Hubble Space Telescope and made famous to a wider audience by the film Interstellar, stand as another testament to the nebula's power to enchant. These colossal columns of interstellar gas and dust rise like ancient monoliths, towering light years into the void. Within them, infant stars are being forged, their nascent light hidden for now by the veils of dust that surround them. The photograph of these pillars, an image that has become iconic, shows not only the grandeur of the universe, but also its capacity for creation and transformation. The very name, Pillars of Creation, evokes both cosmic architecture and the mysteries of Genesis. To gaze upon a nebula, whether through the lens of a telescope or through the artistry of popular culture, is to encounter the sublime. The colors we see in photographs, brilliant blues, fiery reds, emerald greens, are both real and interpretive. Some are assigned by astronomers to indicate the presence of different elements, hydrogen, oxygen, sulfur. Others are enhanced or shifted to make the invisible visible, translating wavelengths of light far beyond human vision into a spectrum our eyes can appreciate. This interplay between reality and representation is itself a dance of science and imagination, a reminder that what we see is always mediated, always a translation of the universe's language into our own. Across the centuries, nebulas have inspired not only astronomers, but also poets, storytellers, and dreamers. In ancient times, the faint, cloud-like smudges on the sky were sources of wonder and speculation, mistaken for the souls of gods or the breath of celestial beasts. Today, they continue to haunt our collective imagination, appearing in films, literature, and the visual arts. The Horsehead Nebula has made its spectral cameo in Star Trek, conjuring an air of mystery and danger as the crew of the Enterprise navigates the unknown. The pillars of creation, by contrast, serve as symbols of hope and renewal, reminders that even in the coldest reaches of space, the forces of birth and transformation are ever at work. It is perhaps natural, then, that many people associate nebulas with the final acts of cosmic drama, the death throes of stars. Indeed, some nebulas are the remnants of stellar cataclysms. The Crab Nebula, for instance, is the vestige of a supernova witnessed on Earth nearly 1,000 years ago, its filaments of gas and dust hurled outward by the explosive demise of a massive sun. The sight of such a nebula, glowing with the energy released in that ultimate surrender, can feel like a cosmic elegy, a requiem sung across the void. But here let us pause and gently brush away this veil of misconception. For not all nebulas are tombs, many are in fact cradles. The universe, in its infinite subtlety, is not content with simple cycles of birth and death. Nebulas can be both the ashes of what was and the wombs of what will be. They are the stellar nurseries where new stars ignite, kindling their nuclear fires from the raw materials scattered across the galaxy. Within these glowing clouds, gravity gathers the dust and gas, compressing them until the heat of creation is inevitable. The darkness of the nebula is not an absence, but a promise, a quiet anticipation, as if the universe itself is holding its breath. The Orion Nebula, visible even to the naked eye as a faint blur below Orion's belt, is perhaps the most famous of these stellar nurseries. Through a telescope, it blossoms into a complex structure, radiant with the light of young, hot stars. These newborn suns are still wrapped in swaddling clouds of gas, their energy ionizing the hydrogen around them and causing it to glow with a soft, ethereal light. The nebula is alive with creation, a place where the future of the galaxy is being written in the language of thermonuclear fusion. In many ways, the nebula is the universe's great storyteller, weaving together the threads of past and future, destruction and creation. Its forms are mutable, shaped by the winds of stars, the shock waves of supernova, and the inexorable pull of gravity. There is no single origin story for a nebula. Rather, there are as many stories as there are clouds in the sky. Some are born in the fierce aftermath of stellar death, their gases torn from the heart of a dying sun. Others arise in the quiet spaces between the stars, where the interstellar medium gathers and cools, coalescing into vast, diffuse clouds. Consider for a moment the way a nebula's appearance changes depending on how we look at it. In visible light, we see the glowing outlines of gas, reds from hydrogen, blues from oxygen, greens from sulfur. In infrared, the picture shifts. The dust becomes transparent, revealing the hidden stars within. In radio waves, even colder clouds emerge, their molecular secrets laid bare. Each wavelength tells a different story, each perspective adding another layer to the nebula's mystery. This multiplicity of forms and functions is echoed in the names we give to nebulas. Some are named for their resemblance to earthly creatures or objects: the Eagle Nebula, the Cat's Eye Nebula, the Butterfly Nebula. These names are invitations to imagine, to find the familiar in the strange, to link our small world to the vastness beyond. Others are named for the processes that shape them: emission nebulae, reflection nebulae, dark nebulae, planetary nebulae. Each type tells us something about the physical conditions within, about the interplay of light and matter, energy and structure. The emission nebula, like the Orion Nebula, glows with the light of ionized gas, energized by the ultraviolet radiation of nearby stars. The reflection nebula, by contrast, shines with borrowed light, its dust scattering and reflecting the glow of neighboring suns. Dark nebulae, such as the Horsehead, are defined by their absence, by the way they blot out the stars behind them, veiling the sky in mystery. Planetary nebulae, despite their name, have nothing to do with planets. They are the cast-off envelopes of dying stars, expanding into space in delicate shells. Each of these forms is a variation on the theme of transformation, a testament to the endless creativity of the cosmos. There is a quiet paradox in the way nebulas are both ephemeral and enduring. On human time scales, they appear eternal, their shapes fixed in the deep sky. Yet in the language of the cosmos, They are transient, formed, reshaped, and dispersed over millions of years. The pillars that rise today will crumble tomorrow, their material recycled into new stars, new planets, new stories. To witness a nebula is to see a moment in a process that stretches across eons, a single frame in the film of galactic evolution. Popular culture, with its penchant for the dramatic, often leans into the mythic qualities of nebulas. Films like Interstellar use their imagery to evoke the unknown, to suggest that beyond the limits of our world lies something both beautiful and terrifying. Science fiction writers fill their stories with nebula clouds, hiding alien civilizations or cosmic mysteries. Yet even as we wrap them in legend, the reality of nebulas remains more wondrous still. They are not merely backdrops for adventure. They are the stage upon which the drama of existence itself unfolds. In the end, perhaps it is this duality, the way nebulas can be both cradles and graves, both reality and myth, that makes them so captivating. They invite us to look beyond the everyday, to imagine the universe not as a cold expanse, but as a living, breathing entity, forever in flux. When we look up at the night sky, we are peering into our own past and future, tracing the outlines of the clouds from which we ourselves were born. For within these clouds, these glowing, shifting nebulae, lie the seeds of worlds yet unmade. The atoms that make up your body, the iron in your blood, and the calcium in your bones were once forged in stars and scattered by the winds of nebulae. To contemplate a nebula is to contemplate your own origins, to sense the deep kinship between self and cosmos. And so, as the night deepens and your thoughts drift outward, let your imagination linger among these ethereal clouds. See the shapes of dragons and horses, of pillars and wings, painted across the sky. Know that within their luminous folds, the universe is always at work, destroying, creating, transforming. The nebula is not an end, but a beginning, a reminder that from the ashes of what was, new wonders are always waiting to be born. Somewhere in the quiet heart of a nebula, the next star is gathering its strength, preparing to ignite and shine its light across the ages. The story continues, written in gas and dust, in light and shadow, in the endless dance of creation that defines our universe. Across the silent ocean of night, where stars shimmer like ancient lanterns, there dwell vast and delicate clouds of matter, the nebulas. These are not mere embellishments upon the galactic quilt, but essential dynamic players in the ongoing story of the cosmos. Their forms, so hauntingly beautiful to earthly eyes, are born from the interplay of gravity, radiation, and time itself. Tonight, let us journey deeper into these celestial mists, exploring their varieties, their inner architecture, and the mysteries that still elude even our most advanced instruments. Nebulas are the great theatres of change in the universe, and yet to the unaided eye most appear as little more than faint smudges, whispers of light on the edge of perception. Through the lens of a telescope, however, what seemed faint and formless transforms into intricate landscapes, veils and knots, tendrils and pillars, stretching across years of light. the true scale is almost incomprehensible. A typical nebula may span dozens or even hundreds of light years, its ghostly arms cradling enough material to form thousands of suns. Yet paradoxically, their substance is so tenuous that, if you stood within one, you might not realize you were surrounded by it at all. A cubic centimeter could contain just a handful of atoms, compared to the billions that fill the same space in the air we breathe. Within the cosmic taxonomy, nebulas fall into several distinct categories, each defined not only by its appearance, but by the subtle and profound interactions of matter and energy that shape its essence. Let us first turn our gaze to the emission nebulas, among the most flamboyant and celebrated of their kind. These are the universe's glowing beacons, set aflame by the intense radiation of newborn stars. Picture a region of cold, dark, molecular gas quietly drifting through the galaxy. Then imagine the birth of massive hot O or B-type stars within its heart, stellar giants with surface temperatures reaching tens of thousands of degrees. Their searing ultraviolet light floods the surrounding clouds, stripping electrons from hydrogen atoms, ionizing the gas. As the electrons recombine with protons, photons are released, most notably the characteristic red glow of hydrogen alpha light. This is the light that paints the Orion Nebula, the Lagoon Nebula, and countless others in vivid otherworldly hues, but emission is only half the story. Often, in the same region or nearby, we find reflection nebulas, clouds of dust and gas that do not shine with their own light, but instead borrow and scatter the light of neighboring stars. Their beauty is subtler, a soft blue glow reminiscent of twilight on Earth. This blue tint arises for the same reason the daytime sky is blue. Shorter wavelengths of light scatter more efficiently off small particles. The Pleiades cluster, surrounded by delicate wisps of reflection nebula, demonstrates this interplay with quiet grace. Unlike their emission counterparts, reflection nebulas require merely the presence of starlight and dust, not the intense ionizing energy of the most massive stars. Then there are the enigmatic dark nebulas, the cosmic shadows that blot out the stars behind them. They are easy to overlook, for they do not emit or reflect light, but rather absorb and obscure it. Their presence is betrayed by the absence of starlight, by the winding lanes of darkness that snake across the Milky Way's bright core. The Horsehead Nebula, silhouetted against the glowing curtain of the Orion complex, stands as an iconic example. Here, dense concentrations of dust and cold gas block the passage of visible light, creating a silhouette more profound than any brushstroke. But within these cold, dark cradles, some of the most dramatic events in the cosmos unfold. For it is here that gravity gathers material until the conditions are ripe for the birth of new stars, a paradox of apparent tranquility masking profound upheaval. Still more exotic are the planetary nebulas, so named not because they are related to planets, but because early astronomers, peering through crude telescopes, saw them as faint, round disks resembling the distant gas giants. In reality, these are the dying breaths of sun-like stars. As such a star exhausts its nuclear fuel, it sheds its outer layers into space, creating an expanding shell of gas illuminated by the intense ultraviolet radiation from the hot, exposed core. The result is a glowing bubble of intricate structure, often featuring concentric rings, arcs, and even delicate filaments. The Ring Nebula and the Cat's Eye Nebula are among the most famous, their haunting symmetry belying the chaos of stellar death. And at the far end of the spectrum lie the supernova remnants, the aftermath of the most violent stellar explosions. When a massive star's core collapses, it unleashes a shockwave that tears through surrounding space, compressing and heating the interstellar medium. The Crab Nebula, with its tangle of filaments and its pulsar beacon at the heart, is a monument to such cosmic violence. The expanding remnants of the explosion glow across the electromagnetic spectrum, from radio to X-rays, as high-energy particles slam into the surrounding gas and dust. These remnants enrich the galaxy with heavy elements, seeding future generations of stars and planets. Each of these types of nebulas, emission, reflection, dark, planetary, and supernova remnants, occupies a unique place in the cycle of stellar birth and death. Yet they often coexist, intertwine, and transform. A single region of space may host several varieties at once, and over time one may evolve into another. The boundaries are as fluid as the clouds themselves. Within these vast clouds, the architecture is profoundly complex. At first glance, images of nebulas like the Eagle Nebula's pillars of creation or the intricate filaments of the Veil Nebula may seem to defy explanation. Yet science has begun to peel back the layers, revealing a tapestry woven from the laws of physics. The structure of a nebula is shaped by turbulence, magnetic fields, shock waves, and the relentless tug of gravity. Within the denser pockets, molecular clouds, gravity draws matter inward, compressing and heating it until nuclear fusion ignites and a new star is born. Stellar winds and radiation from nearby young stars carve cavities, sculpting pillars and globules, while supernova shockwaves can trigger further rounds of star formation. On microscopic scales, nebula dust grains, composed of silicates, carbon, and ices, play a crucial role. These particles, though individually minuscule, collectively shape the nebula's opacity, its temperature, and even the chemistry within. Molecules form on the surfaces of dust grains, and their presence is detected by subtle fingerprints in the infrared and radio spectra. In the coldest, densest regions, complex organic molecules, precursors to life, have been found, hinting at connections between cosmic chemistry and the origins of biology. Yet for all we have learned, nebulas remain deeply enigmatic. Their boundaries are often ill-defined, their lifespans uncertain. The processes that govern their formation and evolution are shaped by a chaotic interplay of forces: gravity, radiation, magnetic fields, turbulence, whose precise balance is still being unraveled. Even the question of how molecular clouds first coalesce from the thin interstellar medium is a subject of ongoing investigation. Do they form gradually as gas slowly accumulates and cools, or are they born in the wake of violent events, such as the passage of spiral arms or the shockwaves of ancient supernovae? Observations reveal both possibilities, and simulations struggle to capture the full complexity of the process. Consider, too, the paradox at the heart of every nebula. To our eyes, they seem serene, as if frozen in time. Yet they are scenes of relentless activity, matter flowing, stars igniting, winds blowing at hundreds of kilometers per second. In the Orion Nebula, for instance, proplyds, protoplanetary disks, circle newborn stars, their outer edges sculpted by the fierce radiation of hot neighbors. Jets of gas ejected from the poles of forming stars pierce the surrounding clouds in narrow beams, lighting up as they slam into denser material. Bow shocks ripple through the nebula, compressing gas and dust, sometimes creating new sites of star formation. The apparent calm is an illusion born of scale. The drama unfolds on time scales of tens to hundreds of thousands of years, a blink in cosmic terms, yet far slower than any human life. Within these dynamic environments there is also an ongoing dialogue between stars and their birth clouds. The energy released by young massive stars can disperse the gas and dust, halting further star formation in the immediate region. But the same winds and radiation can also compress surrounding material, triggering new waves of stellar birth. Nebulas are thus both cradles and destroyers, their fate entwined with the lives of the stars they nurture. The limits of our understanding are not merely technological, but conceptual. We peer at nebulas across the electromagnetic spectrum, radio, infrared, visible, ultraviolet, X-ray, each wavelength revealing different secrets. Yet many aspects remain shrouded. Magnetic fields, for instance, are notoriously difficult to measure, yet they are thought to play a crucial role in shaping nebular structure and regulating star formation. The origins of turbulence in molecular clouds, the initial mass function of stars that form within them, and the processes that lead to the formation of planets within protoplanetary disks, all are subjects of ongoing inquiry. And there are deeper enigmas still. What determines whether a cloud of gas will fragment into a cluster of stars or collapse into a single massive one? How do the complex molecules found in some nebulas survive the harsh environment of space, and what role might they play in the emergence of life elsewhere in the cosmos? Nebulas are laboratories for chemistry on a grand scale, yet we have only begun to decipher their recipes. As we contemplate these celestial clouds, there is a sense of standing at the edge of a vast, uncharted territory. Each new observation, each theoretical advance opens further questions. Nebulas are not merely passive backdrops to the drama of the stars, but active participants, shaping and being shaped by the forces at play. Their forms are fleeting, their beauty transient, but their influence endures, echoing through the cycles of creation and destruction that define the universe. In the quiet hours of the night, as starlight filters through the atmosphere and the shapes of distant nebulas drift across the mind's eye, one cannot help but feel both humbled and invigorated by the mysteries that remain. For all our progress, the nebulas keep many of their secrets close, inviting us ever deeper into the cosmic dance. And so, with our journey through their veils and shadows only just begun, we turn our attention to the next frontier, the birth of stars themselves, hidden within these enigmatic clouds, where the seeds of light are sown and the future of the galaxy is forged. When night settles over the silent countryside and the last golden blush of sunset yields to darkness, the sky above transforms into a velvet canvas dusted with stars and faint, ghostly clouds. These ethereal clouds, nebulas, have beckoned human curiosity for centuries, their shapes and colours hinting at secrets woven deep within the fabric of the cosmos. Yet, for most of history, their mysteries were hidden behind the limitations of our eyes and the simple lenses of early telescopes. Only in the last few centuries have we begun to truly lift the veil, crafting ever more ingenious tools and methods to decipher their secrets. Let us first turn our gaze to the tools themselves, the eyes and ears with which astronomers peer into the heart of the nebulae. The earliest telescopes, like those wielded by Galileo Galilei in the early 17th century, were little more than tubes fitted with simple glass lenses, but even so they revealed wonders undreamed of. Galileo himself, one cold winter's night in 1610, turned his telescope toward the sword of Orion, just below the trio of stars that marks the hunter's belt, and saw not the plain misty patch described by earlier stargazers, but a swirling luminous cloud, alive with faint stars. The Orion Nebula, as it would come to be called, was one of the first hints that the universe held more than just solitary pinprick stars. As centuries passed, the telescopes grew in size and sophistication. Mirrors replaced lenses, allowing for ever larger apertures to gather faint light. On mountain tops, far from the haze and glow of city lights, vast observatories rose, great domes housing telescopes whose mirrors stretched 6, 8, even 10 meters across. The optics, polished to perfection, could catch the dim whisper of light from nebulas tens of thousands of light years away. At the Palomar Observatory in California, the 200-inch Hale telescope was, for much of the 20th century, the world's mightiest eye on the sky, mapping the intricate filaments of the Crab Nebula and the glowing shells of planetary nebulas scattered throughout the Milky Way. But ground-based telescopes are prisoners of the Earth's atmosphere. Even on the clearest nights, the air shimmers and shifts, blurring the finest details. To truly escape these earthly shackles, astronomers looked upward, out into space itself. In 1990, the Hubble Space Telescope unfurled its solar panels and opened its eye to the universe. Floating above the distorting atmosphere, Hubble could see with a clarity and depth never before possible, or, with its sharp gaze, it captured the tapestry of the Eagle Nebula's pillars of creation, dark columns silhouetted against a glowing haze, where new stars ignite from clouds of dust and gas. The sheer wealth of detail, the knots, tendrils, and shock fronts turn the abstract beauty of nebulas into a living story of birth, destruction, and transformation. Hubble is not alone in its vigil. The Spitzer Space Telescope, using infrared detectors, could pierce through clouds of dust opaque to visible light, unveiling newborn stars swaddled in their natal cocoons. The Chandra X-ray Observatory, peering at higher energies, revealed the hot, violent underbelly of supernova remnants, where shock waves from stellar explosions heat gas to millions of degrees. On the ground, arrays like the Atacama Large Millimeter Submillimeter Array, or ALMA, spread across the high deserts of Chile, listen for the faint radio whispers of cold molecular clouds, places where complex chemistry unfolds in the dark. Each wavelength of light tells a different chapter of the nebula's story. Visible light shows us glowing hydrogen and oxygen sculpted into wisps and loops by ultraviolet radiation. Infrared reveals the hidden heat of dust and the signatures of organic molecules. X-rays and radio waves trace the most energetic and frigid processes alike, probing the extremes of temperature and density. In concert, these instruments allow astronomers to peel back the layers of a nebula like a botanist dissecting a flower, revealing its structure, history, and fate. But telescopes alone, however mighty, are only the beginning. To truly understand what nebulas are made of, how they change, and what they might mean for the cosmos, astronomers must turn to an even more subtle tool: spectroscopy. The principle is both simple and profound. When light from a nebula passes through a prism, or more precisely, a diffraction grating, it fans out into a rainbow, its spectrum. But this is no ordinary rainbow. Within it lie dark and bright lines, fingerprints of the atoms and molecules within the nebula. Each chemical element absorbs and emits light at characteristic wavelengths determined by the structure of its electrons and the rules of quantum mechanics. Hydrogen, the most abundant element in the universe, blazes with a deep red glow at 656 nanometers, the H-alpha line, when its electrons drop from the third to the second energy level. Oxygen, when doubly ionized, shines with a ghostly green. By carefully measuring the positions and intensities of these spectral lines, astronomers can deduce not only the composition of a nebula, but also its temperature, density, and motion. Take, for instance, the Orion Nebula. When astronomers aim their spectrographs at its glowing expanse, they see a forest of emission lines, bright red from hydrogen, sharp green from oxygen, faint blue from helium, and many more. The relative strengths of these lines reveal the temperature of the gas, often around 10,000 degrees Kelvin, and the abundance of each element. By measuring the slight shifts in wavelength caused by the Doppler effect, they can even map the flows of gas within the nebula, tracing the turbulent dance of material as it collapses into new stars or is blown outward by stellar winds. Spectroscopy has yielded more than just inventories of elements. In the vast, cold dark of molecular clouds, where temperatures plunge to just a few tens of degrees above absolute zero, molecules form, simple ones like carbon monoxide, ammonia, and water, but also more complex, organic species. In the early 2000s, astronomers using radio telescopes detected glycine, the simplest amino acid in the interstellar medium. More recently, with ALMA's sharp gaze, they have found even richer chemistry, ethyl formate, which gives raspberries their flavor, formamide, a precursor to nucleic acids, and even chiral molecules, whose handedness is a key feature of life on Earth. These discoveries have profound implications, for they suggest that the raw ingredients of biology may be widespread in the universe, assembled in the dark cradles of nebulas long before planets form. This interplay of observation and analysis is not limited to what we can directly see. In the modern era, computer simulations have become a vital thread in the fabric of astronomical discovery. The physics of a nebula is dauntingly complex. Clouds of gas and dust interacting over millions of years, governed by gravity, electromagnetism, hydrodynamics, and the relentless pressure of stellar radiation. No single equation can capture it all. But with the power of supercomputers, astronomers can construct virtual nebulas, digital sandboxes, where the laws of physics are played out in exquisite detail. In these simulations, clouds of hydrogen swirl and collide, birthing dense knots where gravity takes hold. The virtual gas cools and fragments, forming protostars that flare to life and begin to sculpt their surroundings. Shock waves ripple outward from exploding supernovae, triggering new waves of star formation or dispersing clouds altogether. By comparing these synthetic nebulae to actual observations, matching the shapes, spectra, and motions seen in the sky, astronomers can test their understanding, refining their models until they mirror reality. Sometimes the simulations reveal processes hidden from direct view. For example, they show how turbulence within a molecular cloud determines the masses of newborn stars, or how magnetic fields thread through the gas, channeling flows and shaping filament. They suggest that feedback from newborn stars, winds, radiation, and supernovae can both trigger and quench further star birth, weaving a feedback loop that governs the evolution of galaxies themselves. In this way, nebulas become not just objects of study, but cosmic laboratories, where the universal laws of physics and chemistry are tested on a grand scale. Historical discoveries have often sprung from the marriage of new tools and fresh ideas. When William Herschel, in the late 18th century, swept the sky with his powerful reflecting telescope, he catalogued hundreds of nebulous patches, some later revealed as galaxies far beyond the Milky Way, others as true nebulae within our own galaxy. In the 19th century, the spectroscope transformed astronomy from a science of position and motion to one of composition and process. When William Huggins in 1864 pointed his spectroscope at the Cat's Eye Nebula, he saw bright emission lines, proof that it was a cloud of glowing gas, not a cluster of unresolved stars, as some had thought. The story continued in the 20th century, as astronomers like Cecilia Payne and Ira Bowen decoded the meaning of mysterious spectral lines, once thought to represent new elements, but in fact the fingerprints of common atoms in unusual states. In the great dark clouds mapped by radio telescopes, they found the molecules that would feed into the birth of stars and planets. With each new discovery, nebulas became more than just pretty ornaments in the sky. They emerged as the crucibles where the elements are forged and recycled, the wombs where new suns are born, the alchemical kitchens where matter is transformed. As the 21st century dawns, the pace of discovery has only quickened. Space telescopes like Herschel and JWST, with their sensitive infrared eyes, peer into the coldest, dustiest corners of the galaxy, revealing the earliest stages of star and planet formation. Instruments like ALMA and the Very Large Array trace the chemistry of complex organic molecules, mapping their distribution across vast clouds. New generations of computers model entire galaxies, showing how the life and death of nebulas shape the destiny of stars and the evolution of cosmic structure. Yet, for all our tools and techniques, the study of nebulas remains an ever-evolving dance between observation, theory, and imagination. Each new discovery raises fresh questions. How do magnetic fields and turbulence shape the birth of stars? Why do some regions spawn clusters while others remain quiet? What subtle chemistry unfolds in the dark, cold depths, and could it lead, in time, to life itself? From Galileo's first glimpse of the Orion Nebula to the molecular maps drawn by modern radio arrays, our tools have grown in power and subtlety, but the sky remains full of mystery. The nebula, in all its shifting majesty, reminds us that the universe is not static but alive, an ongoing process of creation, destruction, and renewal. With every new instrument, every clever experiment, we peel back another layer, glimpsing the hidden processes that shape the cosmos. Even now, as you listen in the quiet dark, the great telescopes turn their gaze to the heavens. Their mirrors and detectors gather faint photons that have travelled for thousands, sometimes millions of years, carrying with them stories of birth and death, of chemistry and light. The data streams down, raw and cryptic, awaiting the touch of human curiosity to transform it into understanding. And so, as the night deepens, imagine the silent work unfolding atop a snowy mountain or in the vacuum of space, astronomers watching, machines humming, the slow accumulation of secrets that someday will change what we know of the nebula's heart. The story of these luminous clouds is far from finished, and the next chapter, written in starlight and shadow, still awaits discovery. As dusk yields to night, and the sky unfurls its ancient scroll, the mind drifts naturally to the silent, colourful veils that drift among the stars, the nebulas, those vast and mutable clouds, whose very being seems to tremble with meaning. They are not merely astronomical curiosities, nor distant clouds of gas and dust, but ancient story keepers, witnesses and participants in the cycles that bind the heavens to the earth and the living to the inanimate. Their luminous ghosts are etched into our telescopic visions, but also, in a sense, into the very marrow of our bones. Consider for a moment the restless movement of matter and energy that defines a nebula's existence. In their cradles, stars ignite. In their ruins, stars die. These are not events confined to some remote, sterile quadrant of reality. The rhythm that pulses through nebula clouds, the gathering, the burning, the scattering, the recombination, resonates with a pattern that is profoundly familiar. It is the cycle of birth, transformation, and dissolution that pervades all life on our planet, and indeed all existence. On Earth, we witness this pattern in the turning of the seasons, in the growth and decay of forests, in the rise and fall of civilizations, and in the fleeting arc of a single human life. A seed is sown, germinates, grows tall, flourishes, withers, and is ultimately returned to the soil, where it becomes the substrate for new life. In this endless succession of beginnings and endings, nothing is ever truly lost, only changed, only reconfigured. The atoms of a fallen leaf, processed by time and the patient labor of microbes, become the green of new shoots. The water that swells a river's banks once danced in clouds, and before that surged in the veins of ancient creatures now fossilized and forgotten. The nebula, in its grand and distant form, is the cosmic expression of this same cycle. Within its luminous haze, gravity gathers the scattered remnants of older stars. The gas and dust, having drifted for eons through the darkness, are drawn into denser knots. Here, in these cold and crowded nurseries, pressure mounts until the hidden alchemy of nuclear fusion is kindled. A new star is born, bathing its surroundings in light and heat, and perhaps kindling the birth of planets, and eventually of life. But no star, however mighty, endures forever. Some, massive and short-lived, blaze through their fuel in a few million years, an eye blink in cosmic terms, before exploding in supernovae that hurl their innards across light years of emptiness. Others, smaller and slower, quietly shed their outer layers, leaving behind a pale core. In either case, the death of a star is never a finality. Its scattered elements, carbon, oxygen, nitrogen, iron, are reclaimed by the nebula, recycled into the next generation of stars, planets, and perhaps living beings. The nebula is thus both womb and shroud, the place where stars are born and the place where they return. This cosmic rhythm, so elegantly mirrored in the cycles of life and death on Earth, invites us to reflect on the deep kinship between the human and the celestial, the elements forged in the heart of stars, those same elements that drift and swirl in nebular clouds, are the very building blocks from which our bodies are made. Every atom of calcium in our bones, every molecule of oxygen we inhale, every trace of iron that colors our blood, was once fused in the incandescent core of a star, long dead and gone. When we say, as the astronomer Carl Sagan famously did, that we are made of stardust, it is not poetry but fact. The universe's most extraordinary crucibles, these nebulas, are our ancestral hearths. Trace the lineage of a single atom within your body. Perhaps it is an atom of carbon, part of a molecule of DNA, carrying the instructions that orchestrate your very being. That carbon atom was once locked inside an ancient star, perhaps billions of years ago, pressed and fused from lighter elements in the relentless heat of a stellar heart. When the star died, it scattered its contents into the surrounding nebula, which over time coalesced into new stars, planets, and eventually a world where life emerged. That atom, after an odyssey of unimaginable duration and distance, now forms part of you. The journey of matter from nebula to life is a story written across the ages with no beginning and no end. This realization that we are in the most literal sense children of the stars reshapes our understanding of what it means to be alive. It is easy, in the routines and tribulations of daily life, to feel disconnected from the grand tapestry of the cosmos. Yet, the very substance of our bodies is a testament to our origin in distant fires, our kinship with the nebula's luminous haze. The boundary between the earthly and the celestial, between the human and the cosmic, blurs and dissolves. Our lives are not isolated sparks, but continuations of a process that began with the first stars that will persist long after we are gone. Ponder for a moment the philosophical implications of this kinship. To be made of stardust is to be woven into the universe's fabric, not as an accidental bystander, but as an emergent pattern in its long unfolding. The nebula, in its silent grandeur, is a reminder of scale, the scale of time, of space, of transformation. It humbles us, showing how brief and fragile our own lives are against the backdrop of cosmic history. Yet it also ennobles us, for in our eyes the universe contemplates itself, and in our minds the nebula's story is remembered and retold. The study of nebulas thus becomes not only a scientific pursuit, but an act of reverence. When astronomers turn their instruments to the sky and capture the faint, glowing wisps of a distant nebula, they are not merely cataloguing phenomena, they are participating in an ancient dialogue, reaching across the vastness of space and time to touch the origins of matter, the origins of themselves. The images of nebulas, their ethereal shapes and kaleidoscopic colors, provoke a sense of wonder that is both intellectual and spiritual. Why, after all, should the universe possess such beauty? Why should the processes that give rise to stars, planets, and life also produce such haunting, luminous forms? There is no simple answer. Some of the colors we see in nebula photographs are the results of specific atoms emitting light at characteristic wavelengths, a consequence of the quantum mechanics that governs the microcosm. Others are enhanced or combined by the techniques astronomers use to visualize phenomena invisible to the naked eye. Yet the fact that these processes, at once physical, precise, and inevitable, yield such splendor is a kind of miracle. The nebula is evidence that the universe, in its relentless quest for equilibrium, is capable of both violence and grace. In contemplating the nebula, we are reminded of the paradoxes that define our existence. The same forces that create beauty also destroy. The same cycles that give rise to life, in time dissolve it. The nebula's glow is both a birth announcement and a memorial. Its dust is destined to become both star and corpse. And so too with us. Our lives are fleeting, our bodies destined to return to the earth, to be scattered and recombined in ways we cannot foresee. Yet in our fleetingness there is a kind of eternity. The matter that composes us will persist, will take new forms, will participate in new cycles. To study the nebula is to accept our smallness, our impermanence, but also our participation in something vast and continuous. It is to be humbled by the realization that our concerns, our achievements, our struggles are but eddies in a current that began long before we appeared and will continue long after we are gone. At the same time, it is to be lifted up by the knowledge that the universe is not indifferent to us, for we are its children, its thinkers, its storytellers. Through us, the nebula's ancient light is seen and known. There is a certain solace in this perspective. The nebula's story, after all, is not one of permanence or perfection, but of change and renewal. Nothing is wasted, everything is transformed. The patterns we see, the filaments and knots, the veils and pillars, are momentary arrangements, destined to dissolve, but also to give rise to new wonders. In this, there is a lesson for us: to cherish the present, to accept the inevitability of change, to find meaning not in stasis, but in becoming. The sense of wonder that nebulas inspire is, in some ways, a kind of echo, a memory, perhaps, of our own origins in their depths. To gaze at the Orion Nebula, or the Eagle Nebula's pillars, is to look upon the forge in which the seeds of life were sown. It is to glimpse a process so vast and so patient that it dwarfs our imaginings, and yet it is also to recognize the familiar, the gathering of matter, the emergence of complexity, the passage from chaos to order. This wonder is not a passive sensation, but a call to curiosity, to humility, to gratitude. It reminds us that the universe is not a finished work, but an ongoing creation. The nebula, in its shifting forms, invites us to ask questions, to seek understanding, to marvel at the improbability of our own existence. Why should the laws of physics permit such complexity? Why should matter, following simple rules, organize itself into stars, planets, and living beings capable of wonder? These are questions without easy answers, but it is the asking that ennobles us. In the quiet hours of the night, when the world is still and the sky is deep, the nebula's story becomes our own. The cycles of birth and death, of gathering and scattering, are not abstractions, but realities written into our flesh, our breath, our thoughts. We are, each of us, a fleeting arrangement of stardust, given form and consciousness for an instant, before returning to the stream from which we came. And so, as we drift into sleep, cradled by the gentle turning of the earth beneath the stars, the nebula's lesson lingers, a reminder of our origins, our kinship with the cosmos, and the endless capacity for wonder that is our birthright. The universe, in its grandeur and its mystery, is not something apart from us, but the context and substance of our very being. Nebulas, in all their silent splendor, are the bridges between the world we know and the world that made us, ever inviting us to look deeper, to ask, to dream. Somewhere, far beyond the reach of our eyes, a new star is kindling in the heart of a nebula, drawing together atoms that have drifted for billions of years. The cycle continues, unbroken, as it always has, and as it always will. The questions persist, the wonder endures, and the story goes on, waiting for its next telling. As our journey through the swirling colours and quiet mysteries of the nebula drifts to a close, we let its gentle glow settle softly in our minds, like a comet tail fading into the hush of space. May this cosmic lullaby inspire your dreams tonight, and when you're ready to wander among the stars once more, I'll be here with more Dreamtime tales to share. Sleep well, and until next time, keep gazing gently into the night.